Welcome to Brain Vision.
Let's say the internal resistance of the voltmeter be indicated by RV, and this is given to be 10 ohms, and let the 15 mega ohm resistance be indicated by R15. So we calculate the current through the probe and the voltmeter as the voltage across the probe. So basically so we calculate the current through the probe and voltmeter. So this will be equal to voltage across the probe divided by the equivalent resistance. So this is basically from Ohm's law. Now we need to know what the equivalent resistance will be in order to plug it in the denominator. So we have R in series with the parallel combination of RV and R15. So R is in series, so we add this with the equivalent resistance of these two resistors. Now these two resistors are in parallel. So the equivalent resistance of the parallel combination is this. Now VV, which is voltage across the internal resistance, is I times R, the equivalent resistance of these two. This is because this is because RV and R15 are in parallel. So the voltage across these two should be same. So VV should be equal to V15. And V15 by Ohm's law is current flowing through the resistor times the resistance. And here we have to use the equivalent resistance, and equivalent, not this, but equivalent resistance of the internal resistance and 15 mega ohm resistance. So basically let me just show you, it's better to draw a diagram. So this is RV and this is R15, and these two are in parallel and they are then in series with R. So the current flowing is I, which we already calculated, and V is the potential difference from across these 2 points. So this is V, and VV is the potential difference of this resistor. But since these two are in parallel, so the voltage VV will be equal to V15, as I wrote over here. Now you can write this to be equal to, so you can write VV to be equal to V15, and by Ohm's law you can write this to be equal to IV RV or I15 R15. But you don't know what IV is and you don't know what I15 is, but you do know what the total current is that's flowing through the circuit. So instead of going with this method, what you can do, you can choose to take the total current and replace these two resistor by the equivalent resistor, uh, which has a magnitude of this, and multiply it with the current. So that will give you the same answer. So now you are finding the voltage between these 2 points. So you are taking the total current and multiplying it with the equivalent resistance of the parallel combination. in order to find this voltage difference. So in that way, you don't need to find IV and I15 separately and plug them uh, back again over here to find the voltage across the internal resistance. But even if you choose to do that, like find IV or I15 separate first and then plug the expression over here, you'll arrive at the same equation. So VV will be I times the equivalent resistance of the parallel combination, so that is R15. Let me just show you what IV will come out to be so that you can uh, compare both the answers. So IV is, so you have the total current to be I, so I is equal to I plus I15, and then you have IV RV equal to I15 R15 by Ohm's law. Basically I have used this relation and used Ohm's law over here, so this is what I get. And then I've solved these two equations to find IV and plug them back into this equation. So your IV, if you solve these two equations, your IV will come out to be I times R15 over, oops, I'm out of space, over RV plus R15. And then you plug this expression of IV over here next to RV. And ultimately you'll see that this is in fact equal or the same as to this expression. So it doesn't really matter how you choose to go, whatever you feel comfortable with, you can choose that. Now I have this equation and this equation for I. Now I'm going to plug the expression of I over here. So I'll get VV equal to V over R plus R15 times RV over R15 plus RV times R15 RV over R15 plus RV. And simplifying this, like basically I'll multiply all the terms and we'll arrive at this expression. So this is equal to VV. Now we can solve this equation to find the internal, to find R. And doing that, you find R to be equal to V over VV times R15 times RV minus R15 times RV over R15 plus RV. And this is equal to R15 RV over R15 plus RV multiplied by V over VV minus 1. Now we can plug all the values that we have. So let me just write those again. So we have V equal to 50,000 volt, VV equal to 50 volts. I missed a mega ohm here. Sorry about that. So we have RV equal to 10 mega ohm and R15 equal to 15 mega ohm. And plugging all these values over here, you find R to be equal to 5,994 megaohms.